I'm going to talk about some of the technologies that most fascinate me. These technologies are the future of the brain. We're going to begin to change our brains. They can be used to actually move a cursor on a screen.
How is this possible?
Do you know that some people believe that if the human brain can be linked to a machine, it will not be long before others can hack into it and take control of another person's mind?
How is that possible?
In this video, we will be discussing how the brain-computer interface works. So stay tuned and clear your mind of any question you may have regarding the brain-computer interface. To begin with, a brain-computer interface means a direct connection between the human brain and a computer. Brain-computer interfaces are how the brain and external devices such as computers and headsets among others can communicate. The technique works by capturing electrical signals generated by the brain. These impulses are amplified and sent to a piece of software that determines how they should control the computer. Brain-computer interface is devoid of any chemical mechanism. Electric signals must be processed, interpreted, and translated into commands conveyed to output devices to carry out numerous intended functions. If you desire to move your hand, for example, the brain will send a signal to the motor neurons, which then activate the target muscles via neurotransmitters. Doesn't it appear to be simple?
Really?
However, there's a lot more to it than that. If you wonder how the human brain can capture electric signals and send them to the computer, keep watching, since we will be giving a rundown on that soon. Moving forward, if we go back in time, the brain-computer interface was envisioned as a possible replacement for neurological rehabilitation and as a way to operate and command assistive devices directly from the brain. J.J. Vidal used an electroencephalogram to capture the electrical activity and signals of the cerebral cortex from an intact skull in 1973, making this the first step to put brain-computer interface technology into practice. But how can the human brain generate electrical signals when made up of non-conducting tissue? This is accomplished by intricate chemical events that occur when thoughts are generated. In a delicate balance, ions float in and around the brain's neurons. The balance shifts as thoughts and impulses are caused, and the flow of ions to restore it manifest as electrical signals. Therefore, to control a computer, you must first detect and amplify electrical signals from the brain, then translate them into computer actions. If you are enjoying this video, then please subscribe to this channel for similar relevant content. Also, the electroencephalogram, EEG, is a standard tool used by neurologists to track the brain's electrical activity. EEG is the simplest and least disruptive method of recording the brain's electrical output. The signals are subsequently sent to the brain-computer interface software, which uses machine learning, ML algorithms, to recognize EEG readings linked to specific emotions and behaviors. The EEG data is tagged with commands to operate the computer via the algorithms, and the brain-computer interface executes these orders. For instance, if you can move the computer's cursor to the left or right with this approach simply by thinking about going left or right, there's been a recent successful brain-computer interface demonstration that amazed the world, and we will soon share this brain-computer interface demonstration. Furthermore, the use of a brain-computer interface is new and uncharted territory. People are discovering more helpful ways to use technology as they understand how it works. Using it to control equipment remotely is one of the most appealing possibilities. There have been successful attempts to operate robots in adverse areas using brain-computer interface. The brain-computer interface also aids our understanding of the brain's intricate workings, particularly how biological neural networks function in real time. Artificial intelligence and artificial neural network research and development can benefit from brain-computer interface advancements. Researchers are also optimistic about the potential of brain-computer interface technology to improve the lives of persons who have lost limb function. Stephen Hawking, the late famed physicist who had amyotrophic lateral sclerosis, the death of neurons in a patient's brain, communicated his brilliant thoughts by utilizing a device that monitored his movements and synthesized his words. However, brain-computer interfaces would have tapped directly into his brain, allowing him to operate computers in addition to speaking. Again, the possibilities of adopting brain-computer interface technology are tremendous, and we may not even be aware of their entire range. Although EEG is harmless, some sophisticated applications may necessitate implanted sensors that can communicate directly with neurons. However, the technology to do so is not yet fully established, and numerous technological challenges must be handled before reaching this level. Some people are also against brain-computer interface use for ethical reasons. They are concerned that if the human brain can be linked to a machine, it'll not be long before others can hack into and take control of another person's mind. Do you think that the brain-computer interface will give access to individuals and companies to have into people's brains? Let us hear your thoughts in the comments section below. In recent times, there has been a successful demonstration of the brain-computer interface, and an example is Elon Musk's Neuralink demonstration. A 9-year-old macaque monkey named Pagger successfully played Pong with his mind in a brain-computer interface demonstration. While the presentation by Elon Musk's neurotechnology business Neuralink may sound like science fiction, it is proof of a brain-machine interface in action. The Neuralink implant captured the electrical activity patterns in the monkey's brain as he played, and this revealed which neurons were in charge of specific movements. Elon Musk's brain-computer interface aims to aid those paralyzed due to spinal or brain injuries, by allowing them to control technological devices with their minds. This would enable paraplegics, quadriplegics, and individuals with stroke to rediscover the joy of doing things independently. Brain-computer interface technology aims to assist people who have lost muscle control or are paralyzed in completing tasks simply on their own.
The field of brain-computer interfaces relies on the ability of the brain to be able to generate certain types of responses that can then be harnessed by computers, to be able to be interpreted by computers.
We hope you found the video entertaining. If you did, please share this video with your friends interested in the brain-computer interface. Thank you for watching. We'll see you shortly in the following video.